Okay, so, let me define what is hypothesis. Testing of hypothesis. So let me define what is hypothesis. So a hypothesis is a statement about a population parameter. For example, if we are taking mean height of students in a classroom, uh, if mu equal to 156 centimeter, or mean height of the students in the college. Okay. So that is an hypothesis. And there are two types of hypothesis. One is null hypothesis and other one is alternate hypothesis. So what is null hypothesis? It is denoted by H naught. Null hypothesis is denoted by H naught is a claim that is initially assumed to be true. So that is the initial assumption about the population. That means our assumption here is mean height of the students in a college is 156 centimeter. This is the initial assumption about the population, about the height of the students in the college. So this hypothesis is called the null hypothesis. And what is alternative hypothesis? Alternative hypothesis is denoted by H naught or H1. HA or H1 is the assertion that is contradictory to H naught. So any assertion that is contradicting H naught is called a null hypothesis. Sorry, alternating hypothesis. So we have two types of hypothesis. One is null hypothesis and other one is alternating hypothesis. Now the procedure of testing. So null hypothesis will be rejected in the favor of the alternating hypothesis. Null hypothesis is rejected in the favor of alternating hypothesis only if sample evidence suggests that H naught is false. So we have an assumption about its population, and we have so for example, mean of the population mu is equal to 156 centimeter. So this is our assertion about the population. So we can take it as a null hypothesis. That is null hypothesis equal to mu equal to 156 centimeter. So this is the assumption about the population. Now we can take alternative hypothesis that mu not equal to 156 centimeters. So this is a contradicting assertion to H naught. So this is an alternative hypothesis, and or we can take mu greater than 156, or we can take mu less than 156. So these three hypotheses contradicting H naught, therefore these can be alternative, possible alternating hypothesis. Now we will accept or reject H naught or null hypothesis based on the sample drawn from the population. So based on the sample drawn from the population. So now first we will discuss large sample test for population mean. Large sample test for population mean. This is used to test the population mean. Okay. So now I will define what is testing of hypothesis. A test of hypothesis is a method for using sample data to decide whether the null hypothesis should be rejected or not. So by using the sample data, we will decide whether the null hypothesis is rejected or not. Is called is the process of testing of hypothesis. Suppose to test the hypothesis, if the population mean is mu equal to the hypothesis mean mu naught. So I am here taking population mean mu and our hypothesis or h naught is mu naught. Now we can write null hypothesis is h naught is equal to mu naught, and there are possible alternative hypotheses. One is HA is equal to mu naught equal to mu naught. This is two-tailed. I will discuss what is two-tailed test. And this is HA, mu greater than mu naught. It's one-tailed test. And HA, mu less than mu naught. It's also one-tailed. So there are three possible alternate hypotheses. Now I will discuss what is level of significance. The level of significance is denoted by alpha. So alpha is probability of rejecting null hypothesis when it is true. So that probability is called a significance level. That means we are taking so this is our population, suppose. So we are taking a few samples from this population, okay, and we are by using these samples we are predicting the mean of the population. We are predicting or we are testing mean of the population. Then we are taking samples, so there is a possibility of errors, right? So that means level of significance means, that means we are rejecting h naught. We are rejecting h naught. Probability of reject h naught when h naught is actually true. So there is a possibility of that because we are taking only random samples. So that is called a level of significance. So if uh, if alpha equal to 5%, it means that there is 95% confidence of making a correct decision. So alpha is 5%. That means there is a 5% of probability that rejecting h naught when h naught is true. Therefore, if alpha is 5, only 5%, we have 95% confidence that we are making a correct decision. That means probability of accepting h naught when h naught is true has a confidence of 95%. So we have, there are h naught, there are h naught is equal to mu naught, and there are three possible alternate hypotheses, and they are this. Okay. So now we will discuss what is two-tailed test. In two-tailed test, it's like we have to test whether h naught mu equal to mu naught. That means population mean is mu equal to mu naught. Then in two-tailed test, we have alternating hypothesis mu naught equal to mu naught. Mu naught equal to mu naught. This is mu naught. Mu naught equal to mu naught. And there is a two possibilities, right? Either mu less than mu naught or mu greater than mu naught. Okay. So if our test statistics falls in this region is accepted region, and if it is less than some point like here in this region or in this region, that means our mu, based on samples, our mu is greater than some level, like this level, then we will reject h naught. and if our test statistic falls in this region, we will reject H naught, and if it falls in this region, we will accept H naught. So that is two-tailed test, and I will discuss what is two-tailed test. If the significance, for example, if the significance level is alpha percentage, then the probability of rejection region is alpha by 100. In two-tailed test, if significance level is alpha percentage, then the probability of rejection region is alpha by 100. That means significance level is probability of reject H naught when H naught is true. So we will in two-tailed test, we will equally split on both sides. That means here and here. So that means, for example, if significance level alpha equal to 5 percentage, then the probability of rejection region is 0.05 percentage. That means here it is this area is 0.025, and also this area is 0.025. So the rejection region is both 0.05. That means it is equally split on both sides of the curve. So it is equally split on both uh, both sides of the curve. Now the region of rejection is acceptance is here. That means this value is mu naught minus z alpha by 2 sigma by root n, and mu naught plus z alpha by 2 sigma by root n. So now we how to test uh, whether we have to accept H naught or reject H naught. So suppose our population standard deviation is known and it is sigma, and then denote the size of the sample, and the sample space size is very large, then we can use this test statistic. So then we are taking z equal to x bar. We know that x bar follows normal distribution with mean mu and standard deviation sigma by root n. Therefore z equal to x bar minus mu by sigma by root n. You can take z as this. Okay, z equal to x bar minus mu by sigma by root n if sigma is known. Now if sigma is unknown and s is sigma is unknown and s is sample standard deviation, then you can take z equal to x bar minus mu by s by root n. So this is the test statistic. Okay. So anybody have any doubt? So what is the test statistic? Z equal to x bar by mu minus sigma by root n. Now, what we will do is, so in two-tailed test, that means two-tailed test is actually we have to test whether mu equal to mu naught and HA must be mu not equal to mu naught. So if it is not equal, then we will take a two-tailed test. So now in two-tailed test, null hypothesis H naught is accepted if mod z is equal to mod x bar minus mu by sigma by root n, x bar minus mu by sigma by root n less than or equal to z alpha by 2. So for where alpha is the significance level. Okay. So this value we will get from the table. What you have to check what is alpha. Usually it is given 0.05, 5 percentage or 1 percentage or 10 percentage. Okay. and this value we will get from the table. And if reject h naught when mod z is equal to x bar minus mu by sigma by root n greater than z alpha. So in two-tailed test, first we have to calculate what is x bar z equal to x bar minus mu by sigma by root n, and then if we calculate z bar and if it is less than or equal to z alpha by 2 from the table, then we will accept h naught and reject h naught when z greater than z alpha by 2. Okay, so this is very important. So you note it down. Null hypothesis is accepted when z bar mod z less than or equal to z alpha by 2 and rejected when mod z greater than z alpha by 2. Now next is one-tailed test. There are two types of one-tailed test. One is left-tailed test and second one is right-tailed test. Okay. So left-tailed test is, here we have h naught. Our assumption is mu equal to mu naught, and in left-tailed test is our alternating hypothesis mu less than mu naught. Okay, mu less than mu naught. In right-tailed test, h naught is same, mu equal to mu naught, and h is mu greater than mu naught. So in this case, okay, so in left-tailed test, what we will do is, the left-tailed test is we have to test h naught is mu equal to mu naught, and we have to test whether it is mu less than mu naught. So mu less than mu naught. So if some quantity, if mu is less than in this region, if our z is less false in this region, then we will reject h naught, right? So that means z is less than this quantity, we will reject h naught, and if z greater than this quantity, that is z minus z alpha, that means this quantity, if z falls here, then we will accept h naught. So you know that in left test, accept h naught if z bar minus mu by sigma by root n greater than minus z alpha. That means this is negative, right? In the left side it's negative h naught, and z equal to z bar minus mu by sigma by root n is less than minus z alpha, then we will reject h naught. So in left-tailed test, if z greater than minus z alpha by 2, sorry, z alpha, because uh, it's only a one-tailed test. Okay, and reject if z less than minus z alpha by 2. So similarly, right-tailed test. So we know that in right-tailed test we have h naught is mu equal to mu naught, and we have to test whether h is mu greater than mu naught. So when we accept HA, that means when we reject HA, if our test statistics Z is greater than some value, this value, okay, then we will reject H naught. That means if Z value is somewhere here, then we will accept H naught. Okay, so that is, if Z is equal to x bar minus mu by sigma by root n is less than Z alpha, that means is less than somewhere here, then we will accept H naught. That means this is the correct answer. Or if Z greater than or equal to Z alpha, we will reject H naught. So let us recall what is two-tailed test and test. So we have a summary. So what we have to do, we have to check whether the null hypothesis mu equal to mu naught is we need to accept or reject it. So in two-tailed test, that means HA must be is of the form mu naught equal to mu naught. So this we have to test. So for that, in order to accept H naught, we will with the sigma level alpha is equal to that means level of significance alpha. If our test statistic z equal to mod x bar minus mu by sigma by root n is less than z alpha by 2, because here uh, it may lies in this region or in this region, left or right. That's why we are divided it into, split it into 2. Then we accept H naught, and if mod Z greater than Z alpha by 2, we will reject H naught. And this value Z alpha by 2 we will get from the table. Okay. So similarly, in one-tailed test, left-tailed test, H naught is same, mu equal to mu naught, and H is mu less than mu naught. So in order to show that mu less than mu naught, we will put this value. That means if our z is less than some value minus Z alpha by 2, then or sorry, if Z greater than minus Z alpha by 2, that means this is Z alpha by 2. If the value is greater than that, that means it falls in the acceptance region. This region, this is acceptance. Then accept H naught. If it is Z less than minus Z alpha by 2, that means this it reject H naught. Okay. Similarly, we will do right test. So while doing the problem, you will understand. Now I will define how the procedure works. So in order to test population parameter for mean, first procedure is you have to stating the hypothesis. What is the hypothesis? That means mean is equal to something mu naught. Then we have to construct what is null hypothesis, that is the given assertion, and what is alternating hypothesis from the question. Now we have to identify test statistic, that is Z. If sample says n is very large, that is greater than 30, we can use, and standard deviation is known, then you can take z equal to x bar minus mu by sigma by root n. And also if n is very large and standard deviation is unknown, then you can take z equal to z bar minus mu by s by root n. This is sample standard deviation. Then we have given from the question, it will give level of significance. If it is not given level of significance, you should take 5%. So the level of significance is the maximum value of the probability of rejecting the null hypothesis when it is true, and is usually determined in advance before testing of hypothesis. So that is level of significance means the probability of rejecting H naught when it is true, maximum. Now fourth step is determine the value of test statistic. Check whether the null hypothesis is accepted or rejected. Okay. So now you have to take normally they will ask level of significance 1%, 5%, or 10%. So you can get this value from the table, or you just by heart it. In two-tailed test, 1% of significance level Z alpha by 2 is 2.58. 5% significance level is 1.96, and 10% significance level is 1.645. So this is for two-tailed test. Two-tailed test is when we are testing mu equal to mu naught and H is mu naught equal to mu naught. Now right-tailed test, it's sigma alpha when 1% of significance level is 2.1, 2.33. That is actually what is the probability of mod Z less than Z alpha by 2 is equal to alpha by 2. So that quantity is Z alpha by greater than. Okay. So here Z alpha is 1.46. So you have to, when it is 10%, Z alpha is 1.25. In left side, just you put negative value. Z alpha is minus 2.33. Z alpha here when 5% of significance level minus 1.645, and Z alpha is equal to minus 1.28. So you have to by heart this, and normally they will ask 5% of significance level. So Z alpha by 2 is 1.96 when 5% of significance level in two-tailed test. Z alpha is equal to 1.465, and in right tailed, and minus 1.645 in the left. Now we will define what is two types of errors are there. Type of error. So there are two possibilities. Four possibilities. One is if H naught is actually true, then accept H naught. That is a correct decision, right? So this is the correct decision. When H naught true ആണ്, അതേസമയം H naught accepting. Now if H naught is true and reject H naught, so that is a wrong decision. Okay. H naught is true, then reject H naught. It's a wrong decision. And H naught is false. Suppose H naught is false and we are accepting H naught, then this is a wrong decision, and it's called a type 1 error. What is type 1 error? One error. It's a probability of reject H naught when H naught is, sorry, This is probability of accept H naught. That means we are accepting H naught when H naught is false. Probability of accepting H naught when H naught is false. That is type 1 error. Type 2 error is probability of this uh, accept H naught probability of reject H naught when H naught is sorry, this is not type 2 error. This is correct decision, right? So type 2 error is actually here it is probability of accepting H naught when H is true. Okay. Accepting H naught accepting H naught when HA is true. So I will define here the probability of rejecting H naught when H naught is true is called alpha, is denoted by alpha, or it is called type 1 error, or level of significance or type 1 error is same. That is probability of rejecting H naught when H naught is true. So here I made a mistake, right? Type 1 error is actually probability of reject H naught when H naught is true. So that is type 1 error. And type 2 error is probability of accepting H naught, that is accept H naught when HA is true. It's denoted by B, or type 2 error when HA is true. Probability of accept H naught when HA is true. Now we will do the problem. Then you will understand how we can do. Anybody have any doubt? So if we are doing the problem, you will understand how to make decision. So first of all, I will discuss a problem. A manufacturer of sprinkler system used for fire protection in office buildings claims that the true average system activation temperature is 130. So what is a manufacturing sprinkler systems claim? It claims that true average of self system activation is 130. Okay. So we can take here given 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 population mean mu equal to 130. So this is given, right? And a sample of 9, so n equal to 9 systems when tested. So we are testing 9 systems from the we are taking 9 systems, and we are taking the sample average activation temperature. So I am taking 9 system, and we are taking the sample average, that is x bar is equal to 131.08. 131.08. Okay, so sample average x bar is 131.08. If the distribution of activation time is normal, and here it is normal distribution with the standard deviation 1.5. So population standard deviation is given. Standard deviation sigma equal to 1.5, right? 1.5. Does so here it is the important. We have to check whether it is tail 2 or tail 1. Does the data contradicts the manufacturer's claim at a significance level 0.01? So our significance level alpha is 0.01. We have to check whether the mean the data contradicts the manufacturer's claim. That means manufacturer's claim is mean is 130, and we have to check whether it contradicts. That means mean not equal to 130. Okay, so we have to test whether mean is 130, and that is you can take as h naught, and mean not equal to 130 you can take as HA. So have we got it? So here what we have given population mean mu, that is given 130, and population standard deviation 1.5, and n samples are drawn, it's 9, and sample mean is also given 131 point. Now our first step is we have to take the null hypothesis. Null hypothesis is h naught, so that is the given assumption hypothesis. So the given hypothesis is used fire protection in the office building claims the average system activation temperature. That means mean they claim is 130. So we have to test whether it contradicts sample values contradict this fact. So the alternating hypothesis is whether mu equal to mu 130 or not. That means HA is mu not equal to 130. Okay, have you got it? So here we have to check whether mu is 130 or not. That means H naught we will take mu equal to 130, and HA mu not equal to 130. So it may be either less than 130 or greater than 130. That's not given. You have to check whether it is 130 or not. So you can take it as two-tailed test. So for that Z, we know that two-tailed test, we are taking Z equal to x bar minus mu by sigma by root 10. Okay, so x bar we know, and minus mu. X bar is given value of x bar is given, and mu is given, sigma is given, and root n is given. So 131.08 minus 130 divided by 1.5 divided by root n, that is equal to 1.08 divided by 0.5. Okay. So 0.5. So the value is 2.16. Now it is a two-tailed test at a significance level alpha equal to 0.01. Then what is a two-tailed test? Significance level is 0.01. So you have to calculate significance 0.05. Then what is test? Z alpha by 2. 0.01 is test. This is 1%. Sigma alpha is 1%. Then we know that Z alpha by 2 is 2.58. 2.58. Okay. Z alpha by 2 is 2.58. So we will do this. So you have to study that value, or otherwise you can take. So Z alpha by 2 is 2.58. 2.58. Therefore, mod z value is we have given 2.16. This is less than 2.58, right? So mod z less than 2.58 is z alpha by 2. So mod z less than z alpha by 2. Therefore, we will accept h naught. So in two-tailed test, we know that h naught mu equal to mu naught and ha mu naught equal to mu naught. If z is mod z is less than z alpha by 2, we will accept h naught. And mod z greater than z alpha by 2, reject h naught. So here mod z is less than z alpha by 2. Therefore, we accept h naught. Therefore, the data does not contradict the assumption. Therefore, its claim supports that the average difference from the design value is 130. So the assumption is true. H naught is true. So now we will move to another problem. So please do this problem. So here first we have to check whether it is a two-tailed or one-tailed test. The melting point of each of 16 samples of a brand of hydrogenated vegetable oil was determined and resulting x bar equal to 94.3. So we have taken 16 samples. So n is 16 and we have given sample mean x bar is equal to 94.32 and assume that the distribution of melting point is normal and with the sigma population standard deviation is given and mu is given 95. The average is given that we have to test. So we have to test h naught mu equal to 95 versus ha mu not equal to 95 at a significance level of 0.01. So here in the question itself we have given mu not equal to 95 and we have to test it ha mu not equal to 95. So this is a two-tailed test. So now we have given everything. So first you have to calculate z x bar minus mu by sigma by root 10, that is 94.32 minus 95 divided by 1.2 divided by root 16, that is minus 2.27. So here our value is minus 2.27 and z alpha by 2. Here alpha is 0.01, that is 1% significance level. And as earlier, it in two-tailed test, if alpha is 1%, then z alpha by 2 is, from the table it is 2.58. Therefore, mod z is equal to, what is mod z value? Z is minus 2.27. Then mod z is 2.27. This is less than z alpha by 2. Therefore, h naught is accepted. So we are accepting the h naught. Okay. So similarly, anybody have any doubts? Okay, can you do this problem? It's very easy if you understand the concept. If you understand the concept, the problem is very easy. So here, a sample of 400 was drawn and the sample mean was found to be 98. So
Sir,
okay, tell me.
sir, time, sir.
Time?
അടുത്ത ഒരു ക്ലാസ് ഉണ്ട്.
Okay. So I will conclude 12:40 AM. Okay. So I will share this. 1 minute.